We're clothing based proximity sensors for the visually impaired. My name is Neilabh Okhandiar. This is Changyul, Yelim Kim, and Youjung Choi. So that's what it does. It sends out a laser, bounces off a wall, comes back to your head. Then it vibrates your skull, and you have detection of like distance. We basically just put it on a hat though, and that way you can take it on and off. So we'll go over the purpose, component, how it works, result, and conclusions. Wait, is that me too? Okay. So we've built it for the visually impaired, so anyone who can't see or just has difficulty seeing. It's not really a replacement to glasses, it's just if you don't have glasses and you don't have sight in general, then you put on the hat and you can detect distance. So it's a wearable device, it detects obstacle and it avoids, and then you can just kind of avoid the collision. If you're going to walk into a wall, it buzzes you, just turn it on. And what you can expect is that it is a solution for a very specific contextual problem, which is that someone who can't see is going to run into a wall, and he can dodge the wall.
I introduce our components. First one is micro Arduino. We are making a wearable product, so we need smaller than the Arduino Uno. We first planned on using the Flora, which was designed for sewing into clothes, but this lacked the necessary number of pins we required. So this micro Arduino has both small size and the same number of pins as the Uno, so it was perfect for our purpose. Next one is input-output sensors. We used ultrasonic range detection sensor. It can calculate the distance by echo pulse width, detecting the reflected ultrasonic. It's a way. And this is a mini vibrator. When the ultrasonic detects a distance less than 70 centimeters, it will begin vibrate. Next, and charging. This is flexible solar panel. It uses light energy from the sun, so when just sunlight is available, it will be used to charge the battery for our systems. And this is charger. It's 3.7 voltage battery. And last one is power boost. The Arduino needs 5 volts, but we just had 3.7 voltage battery, so we have to use it. And finally, we used the touchpad and thread. This thread is made with conductive stainless conductive thread. It functions just like the normal wire, so we sewed it through the head to connect the hardware with Arduino.
This map shows the entire of our product broken into its part. First, we use a Arduino Micro as a controller, and the second, our function is detecting and alarm. So using ultrasonic, we can detect distance between user and obstacles. And then if some obstacles is detected, the vibrator will be used to inform to user about both the direction and distance. The next component was wiring itself. We sewed steel thread throughout the head instead of using wire because it's better it's better when you wear this cap. Finally, is a charge. We use a solar panel, charger, and battery and power boost. This picture is our product. We attach the 3 ultrasonics and 3 vibrations. So if in any direction there is an obstacle, you will be informed and can then avoid it. Here is a diagram. So a user who is wear a cap, when he meet the obstacle, the ultrasonic sensor will detect its distance. Some material operation to transform the distance in milliseconds, and user this as the frequency for our vibrator. As the user comes closer to the obstacle, the vibrator pulses at a fast rate, increasing the strength felt by the user. And then, if the user want to turn off this function, such as when the person who want to talking with another person, at the time, the user can just press the embedded into the front of the cap. And this will shut down or functionally of the head. Another press and the head will resume instantly. This is a battery. When you are outside at daytime, you can charge the battery via solar panel, which is placed on top of the cap. The solar panel outside the solar panel outputs up to 8 volts of electricity, which must be lowered to 3.7 volts to safely charge the battery. Then power is drawn from the battery to the Arduino. However, we require 5 volts to power the ultrasonic sensors. So a step-up device was required between the battery and the Arduino. So we go from 8 volt to 3.5 volt and to 5 volt.
This is our circuit. We use 3 pairs of ultrasonic and vibrator and charger and battery and solar panel and touchpad. Every 20 milliseconds, we detect distance from the detected ultrasonic sensor and turn on relevant vibrator. We will emulate the pulse width modification function by using timer and interrupts. And this is our actual product image. It doesn't look fancy, but it will help people. And we have demo video. This is for testing solar panel is working. This one is also same, but you test by LED. And this one is our final demo video. He can recognize distance with closing eyes. We didn't make new technology. We just combined already existing technology. And in our self-diagnosis, we have these pros and cons. The idea is to support visually impaired people, but however, it costs a little expensive. The components we used is total $200. And when we made it, sewing was the most difficult problem. Thank you.